Biotechnology is changing the world around us, and there are many things for designers, producers, governments, and managers to consider when shaping such technologies for the future. In agriculture, biotechnology can increase the yield of crops engineered to be more disease resistant, which can increase food security. However, the commercialization of biotechnologies is making it easy for organizations to invest in private research and development. Businesses are also patenting groundbreaking genetic modifications for their own benefit. Thus, regulatory environments would need to step in to adjust corporate control of biotechnology so that it can support the interests of society and healthy competition for economic growth. There are also health benefits associated with maximizing the production of plants for nutritious food and pharmaceuticals, but the increase in energy and materials used for production would be higher. This would prompt designers to consider other technologies supporting the genetic modifications, such as hydroponic systems, so that modified plants may be grown indoors and in more places to reduce carbon emissions from their mass production and transportation. Lab-grown meat is another idea to reduce methane emissions from cows. On the topic of environment, biofuels are being created to reduce the dependency on fossil fuels. Certain microbes are also being created in labs to support the biodiversity of ecosystems impacted by global warming. However, the context of biofuel use must also consider how they can be integrated into other future technologies, such as hybrid electric vehicles. Genome-related biotechnology can also be a major step towards improving public health, but for the future of genomics, a shared consensus needs to be built amongst industries, academics, the public, governments, and other various stakeholders to address the values and priorities that would create the best public policy for this technology, and to direct research efforts regarding the vaccines and medicines that may be needed. According to the IAF Future Trends model, one must also recognize trends, key forces, and possible future scenarios shaping biotechnology, which can guide goals and visions for managers and researchers. Design thinking must also be applied to understand in a concrete way what problems biotechnology could solve before thinking about what biotechnology can do. As new technologies are created by combining and modifying existing processes and parts in new ways, technological developments are therefore facilitated by their compatibility with other technologies, as well as standards and systems, which all need to be considered. New advancements in processing and storing genetic information is driving biotechnology, which converges with nanotechnology. Understanding its interrelation with other components and systems, such as big data, will help understand its possible capabilities. Skills and knowledge apparent in a workforce that will support this is also crucial. Labor supply and demand amongst different sectors that could support this technological change would have to consider human resource development strategies, beginning with STEM courses in educational institutions. People's attitudes of perceived risks, ethics, and uncertainty of widespread vaccines or newly modified crops will also impact the technology's adoption.